In this video, we discuss writing equations of hyperbolas in standard form. Why would we want to write an equation in standard form? Because standard forms of equations tell us key features of graphs, and by interpreting the standard form of an equation, we can bridge the gap between geometric and algebraic representations of figures. There are several key features of hyperbolas. Every hyperbola has a center, two vertices, two covertices, foci, two asymptotes, and a transverse and conjugate axis. We will be able to identify all of these features from the standard form of the equation. The standard form of a hyperbola centered at the origin is the point 0, 0, and that has a transverse axis on the x-axis is x squared over a squared minus y squared over b squared equals 1, where the length of the transverse axis is 2 times a, the coordinates of the vertices are plus or minus a comma 0, the length of the conjugate axis is 2b, the coordinates of the covertices are 0 plus or minus b, the distance between the foci is 2c, where c squared equals a squared plus b squared, the coordinates of the foci are plus or minus c comma 0, and the equations of the asymptotes are y equals plus or minus b divided by a times x. So standard form of hyperbola centered at the origin with its transverse axis on the x-axis is x squared over a squared minus y squared over b squared equals 1. Similarly, the standard form of hyperbola centered at the origin, the point 0, 0, with a transverse axis on the y-axis is y squared over a squared minus x squared over b squared equals 1. Notice that the x and y have changed places. Additionally, we notice maybe a few differences. Here, we have coordinates of the vertices, 0, comma, plus or minus a, coordinates of covertices, plus or minus b comma 0, coordinates of the foci 0 plus or minus c, and the equation of the asymptotes y equals positive or negative a over b times x. Take a look at the images of hyperbolas centered at 0, 0. Here in image A, we have a hyperbola whose transverse axis lies along the x-axis. And on the right, we have an hyperbola whose transverse axis lies along the y-axis. Notice any differences that you see in these two figures. We move on to an example. We'd like to identify the vertices and foci of the hyperbola with the equation y squared over 49 minus x squared over 32 equals 1. The first step is to figure out where does the transverse axis lie. Notice the equation has the form y squared over a squared minus x squared over b squared equals 1. And we know the transverse axis lies on the y-axis. We have y over a squared in that first position, which is what tells us the transverse axis lies on the y-axis. Step 2. Where is the center located? This is located at the origin, and therefore our vertices are the y-intercepts of the graph. Step 3, let's find those vertices. Set x to 0 and solve for y. We see here we have 1 equal to y squared over 49 minus 0 squared over 32. This entire term becomes 0 and disappears, leaving us with 1 equals y squared over 49. Multiplying both sides by 49 to clear this 49 gives us y squared equals 49. We take the square root of both sides, and we have y equals plus or minus 7. And thus our vertices are located at the points 0, comma, plus or minus 7. That represents two separate points. One is 0, comma, positive 7, and the other one is 0, comma, negative 7. So now we have our vertices. Step 4, we find our foci. Using c squared equals a squared plus b squared, we solve for c. We have a squared plus b squared given to us in this example. So c squared is merely 49 plus 32. We take the square root of both sides, and we end up with c is plus or minus 9. And we have our foci located at 0, plus or minus 9, again representing two separate points, 0, comma, positive 9, and 0, comma, negative 9.